15 plus years of industry and research experience, our upcoming speaker has more than 10 published research papers under her belt. Armed with a PhD in electronics engineering from IIT Bombay, she has a specialization in cryptology. In her current role at Capgemini, she manages the GRC Cyber Security Department. It's now time to deep dive into an interesting conversation on how secure it is to use cryptography in the blockchain. What are the different kinds of cyber attacks we need to be prepared for? And what are the steps we need to impart to overcome these challenges? Everybody, we bring to you Dr. Shravani Shahapure, coming to your screens right now.
Welcome to the session on Tensorflow Hub. Tensorflow Hub is a repository for pre-trained models. It comes from the Google ecosystem. It's an open source repository, so anybody can go and contribute to it. And now let's see, why do we need such open source repositories like TensorFlow Hub? Let's also understand more about its features. And we'll also be looking through a few examples in image classification, text classification, and style transfer, and how we can use TensorFlow Hub to solve these problems with very few lines of code. It's more important to highlight the phrase very few lines of code, because the context here is that a lot of people who are experienced data science, who are experienced domain specialists having PhDs on certain domains, and they may not necessarily have a machine learning experience. And if they have to, quickly prototype a few things, and TensorFlow Hub comes in very handy. And so it's a great, a tool which is made open source by the Google ecosystem. So now let's see, there are many research papers which are coming almost every 3 days or every week. There's so many research papers in data science which is coming up, but it's very, very difficult to keep track of the research papers. And there's a lot of every research paper author will also share the GitHub repository as well. So it's very, very difficult to keep track of codes and the research papers, versioning and all these things. And you may not know which version is the latest one, because the authors keep changing, because after they publish the papers, they might get additional, thoughts on the paper. They might release a version 2 and things like that. And so there's always a confusion on how to get the latest version. And even if the code is present, sometimes the documentation is not so clear that you don't know how to use that, code which they had shared as well. And so sometimes they don't mention the dependencies properly. So these are some of the issues which are there. And TensorFlow Hub to an extent solves these issues. Let's look at, we have now seen the need for having an open source ecosystem like TensorFlow Hub. And now let's study more in detail about it. So the TensorFlow Hub has got a website called tfhub.dev. So it's outside the tensorflow.org website. So here this website contains a lot of pre-trained models for all types of data, like audio data, text data, video data, and you also have image data for various types of problems. So see, under each of these data types, you have different problem statements. So for example, if you take text, you have something like question answering, text generation, text classification, text embeddings, and the same thing with image. You have image classification, object detection, semantic segmentation, style transfer. So these are some of the use cases in text and image. TensorFlow Hub also contains pre-trained models for video data, for mainly video classification and generation, and audio data, same thing as classification. So these are the different types of data types and different use cases for which the pre-trained models are available in TensorFlow Hub. So, in addition to having, pre-trained models, it also contains it in a format which is easily deployable on different hardware devices. Like, you can deploy it in your mobile using TensorFlow Lite. If it's available in TensorFlow Lite format, it's very easy to deploy it as a mobile application. If it's available as a TensorFlow.js format, it's very easy to deploy it as a browser-based application. So again, there are a lot of use cases where applications are increasingly deployed at the edge. So Corel is another new product which is coming from the TensorFlow ecosystem, which is specifically deals with AI for Edge and the cloud GPUs and AI for Edge section. So you have the pre-trained models in different formats, which you can quickly deploy it as different types of applications. TensorFlow Extended is again for productionizing machine learning models. So these are the variety of formats which are available. These are the variety of formats in which the pre-trained models are available in TensorFlow Hub. So this is how TensorFlow Hub looks like. So you have the problem domain, save file format, whether it's TensorFlow.js or Lite or Corel, what format you want, the publishers, the data set, and the language. So because if you take the data set, the different benchmark data sets on which the model might be pre-trained on, and so that is also very important to filter upon. This is how the pre-trained model looks like. This is a very brief snapshot about how TensorFlow Hub looks. So you have variety of, as we have already seen, under different types of data sets. There are a variety of use cases out there. One is the audio classification, and next is the image classification. Then you also have audio classification, image classification, different types of image classifications, image segmentations. These are some of the use cases available there for which the pre-trained models are available. Using these pre-trained models itself, you can achieve significant amount of accuracy. So it's great for researchers who quickly want to prototype some idea using these pre-trained models. The another important benefit is not everyone has access to great compute resources. So this TensorFlow Hub also comes in handy because, since the model is pre-trained, you're just going to make inference out of it. So it may not require that much of a compute resource. Or imagine, if each one is a training model from the scratch, there's a lot of carbon dioxide emissions which get dispersed into the air. And these carbon dioxide emissions sometimes, especially if it's a huge language model, it is equivalent to an entire lifetime emissions of a car or vehicle, any vehicle. So imagine the scale at which these carbon dioxide emissions get released into the atmosphere. So it's very dangerous. There is a lot of, side effects of training huge models. So we have to be very cautious of that. So open source ecosystem like TensorFlow Hub, Torch, Hugging Face, these are in a lot of ways, saving our planet from climate disaster, and especially in controlling the carbon dioxide emissions as well. And of course, these, tools started out with different intention, but then they are useful in many other ways as well. So you have saved model, and then you have also got a sample notebook. So most of the pre-trained models also comes accompanied by a sample Colab notebook where you have the syntax of how to use a pre-trained model on a particular data set. They already give you a syntax. So all you have to do is take that Colab notebook, adapt it for a different data set by changing few lines of code. And if you don't want to use any sample notebook, you just want the URL directly, that's also possible. Or if you want to download it and then upload it in your application, then that's also possible. So you have the same model in different ways and different formats. So now let's look into a first example, which is the style transfer. So if you take the style transfer, the whole thing concept which I was telling is using TensorFlow Hub, we can just accomplish a lot of tasks by using just few lines of code. And if you see the number of lines of code is just few, like 3 or 4 lines of code. And even those lines of code, you don't have to write it from the scratch. All you have to do is copy paste. And then if you want to use a different model, you just have to change the URL alone. The hub handle, the URL is given, which is the URL on which the model is present. So if you want to use a different model, you just have to change that URL. So what is happening here is you are importing the TensorFlow Hub, and then the pre-trained model location, you're passing it as a parameter to the hub.load method. And then that's it, you've got the pre-trained model now. You can directly make an inference on the pre-trained model. So I just have to give an input image and the style image from which the style has to be, inspired from. Immediately I'll get a stylized image. So with just few lines of code, we were able to accomplish this style transfer. So the same thing with text classification. With just few lines of code, we can accomplish it. So what is happening here is I have, for text classification, the first layer is always an embedding layer. So we have a pre-trained embedding model at this particular URL. And so we are just building an embedding layer by giving this pre-trained model as an input. We are also mentioning the shape and all that. And then we can build a sequential model where the first layer is going to be this embedding layer, which from the pre-trained model. And then you can add a few more layers based on the use case. If it's a text classification with just binary classification, just one node is enough in the final layer. So based on the use case, you will be adding few more layers. And then it's the usual thing. You'll compile your model with certain parameters like optimizer, loss, metrics, and then you'll fit your model. So this is how text classification looks like using TensorFlow Hub. Again, if you see here, it's very few lines of code. So even people with not so strong background in data science can pick up these few lines of code very quickly. And outside these couple of examples, you've also got a lot of examples in the official documentation at tensorflow.hub/hub/tutorials. So there are other things about TensorFlow Hub. So, most of the times we use this TensorFlow Hub pre-trained models because we wanted to achieve performance, right? So we wanted to focus on performance. The other factors which contribute to the performance is if you can cache the model, then, that is also going to speed up the inference process. So where exactly you want to cache all these parameters are also, there are provisions for mentioning all these parameters as well. So what's new with TensorFlow Hub? TensorFlow Hub website is improving every time. And so there are more new features for improved search and discovery. And you have both in TensorFlow 1 version 1 and TensorFlow version 2. You can get the models and you can get it in different formats like JS, Lite, and Coral. So you also get a metadata in addition to TensorFlow Lite format, and you also get TensorFlow.js. So the other extended formats are MLK, Kit Press, Android Studio support as well. So who is contributing to TensorFlow Hub? If you see, there are a lot of contributors from Google, DeepMind, Microsoft, NVIDIA, Metropolitan Museum of Art, Kaggle, and Global Biodiversity. These are the people who are contributing to TensorFlow Hub. And if you are interested in contributing to TensorFlow Hub, you can reach out to this URL, and there will be step-by-step instructions and on how to publish your model. How you can help to the community is you can talk about TensorFlow Hub, and you can also publish the model. So this is the website for TensorFlow Hub. With this, our presentation comes to an end, but I'm also going to show you some of the examples with TensorFlow Hub. So this is the TensorFlow Hub guides and tutorials are there in this official TensorFlow.org website. And Let's also check out the tfhub.dev. So this is the website which we were referring to so far. So if you see, you have all the problem domains here. You can also you have different types of model format, which version you want, who is the data, what is the data set, publisher. So you can filter out based on all these criteria. And for publishing to the TensorFlow Hub, you have the step-by-step instruction here, which is how you should go about publishing the model. So first you should export the model, the documentation, sending the pull request. So the step-by-step instruction here on how you should publish the TensorFlow pre-trained models. And so this tf.hub pretty much contains everything you need to know about TensorFlow Hub. Now let's look at some of the tutorials which we have seen before. Let's look at the complete example end to end. Let's start with image classification. So for TensorFlow Hub, you just have you're importing the all the packages which are required, and then you are writing helper functions to load the image. And once you load the image, for image there are so many pre-trained models available, starting from EfficientNet to ResNet to MobileNet. So this particular piece of code loads all these models, gives you an option to choose any of these methods. So there's a drop down and you can choose whichever model you want and rerun the set, and that particular model will be picked up, because the URL for all these models is given as the key in the dictionary format, key value pair. So whatever model you choose in the drop down will be picked up. The corresponding URL of that model will be picked up. So you can choose a model like that, and you can also choose the image like this. So we're going to use one of these models, EfficientNet. So we're going to you pass that URL as the parameter to hub.load, and we'll get the model object. Once you get the model object, you just have to bring your input image to a certain format shape. And that's it. You can just use this classifier to start making inference. You can just call this classifier of the model object, and you can just pass this input image, and you can start making classification with just few lines of code. We were able to achieve the image classification here. So the next example is the fast style transfer. So this is also an example which we've already seen in these slides. So we'll again look at the end-to-end flow. You are importing a lot of library functions, and then you can choose you can give any URL here, any content URL, any style URL where you want to transfer the style to. And then all you're doing is you're passing the URL where the pre-trained model is there. App.load, you're passing the URL as the parameter. Immediately you get the pre-trained model, and then you can start making inference by passing a content image and style image, and the output which you get is a stylized image. So this is again the use case for style transfer. On the same lines, we can also check out how to do text classification using TensorFlow Hub. So for text classification using TensorFlow Hub, again, you're just importing the the libraries which are required. You're taking a preloaded data set here, which is IMDb reviews. And then, whenever you use a preloaded data set, which is .load function, you can just split it up into train data and test data. And you can see how many examples are there in the training data and in the test data. So from the pre-train, you can give a URL, and from that URL, you can just form hub.keras layer, where you'll be able to get the embedding layer using the pre-trained embedding model here. And then you can just build a simple sequential model with the embedding layer as the first layer. Then you can add 2 more layers based on your use case. So here the fighter is the binary classification problem. So the final layer is just having a single node. So with this, we have built successfully our model. Then the rest of the steps remains the usual thing, where you can just compile your model, give a default optimizer, loss function, metrics, and all that. So this is how, with just few lines of code, you can perform text classification. So there are other examples out there like object detection, and if you go to the official repository, you'll find other examples like object detection. So for example, with few lines of code, you can just detect all these objects. So you also have, human pose detections and with just few lines of code, you can generate images from GANs, and you can also do sound classification, audio recognition. These are some of the use cases, for which the sample notebooks is already given. But the number of use cases which you can solve is almost bottomless. And if you train any of the open source research papers which has come out, and if you're going to train that model, and then you should also consider contributing to the TensorFlow Hub, because that will benefit a lot of people. And at the same time, you can also become an open source contributor as well. So this is about TensorFlow Hub, and we've come to the end of the session. Thank you.